to solve an equation like this. We will need to do this because this would be something like find the equation of the tangent, you know, when slope equals 3, or so that's what this would say, okay? So let's just pretend this is a regular algebra question. 3 times something plus 1. What is the first step I have to do to solve for x? Yeah, go ahead. Very good. So I'm going to call that 2 equals 4 sine 2x. What does that 0 is less than x is less than 2 pi mean? Yeah, go ahead. Right on. So there's going to be lots and lots of solutions. Just as a little bit of a tangent here. Get it? Tangent? What's my period going to be for this graph? I don't recall how to find the period from last semester. Michael, you're in the zone. Go ahead. Very good. Okay, someone other than Michael, you're in the zone. I love it. Okay. What's the k value for this graph? Uh-oh. See, this is why it's good I did this. It's actually this value right here is your k value right there. The number in front of the x. So my period is just going to equal pi. Okay? We're going to need that a little bit later on. Okay, for the question, but I just want to put that in there. Is this coming back to a few people in here? I hope a little bit. Okay, so it says 2 equals 4 sine 2x. Can somebody be brave and show off their algebra skills? Yeah, go ahead. 1/2. Now we're not going to use our calculators here, of course. Sine of what equals 1/2? 5/6. Now is everyone okay? I did that very, very quickly because 1/2 just happened to be on my special triangle. Oh. So that was just on from the special triangles where I got that from. Okay? So anything that has like a pi over... Oh, Brandon. Unfortunately, someone stole your seat today, so you don't have to deal with that. However you will. Okay, so great. How do I solve for x then now? Yeah, go ahead. Okay, so you have x equals pi over 12. Okay, please don't tell me that equals 15 degrees because we're dealing with radians here in calculus, and I'm going to show you why today. Is everyone okay on the first solution here? Because there's going to be many, many more solutions. Are we okay on the first one? Tanner, we're doing okay? Okay, in one cycle of a graph, you remember looks like this, right? Or something like this. So we're doing with sine, so it looks more like this. How many solutions are we going to have in one cycle? No, 2. 2, 2, 2, 2, 2. Now just watch. If here's my graph like this, and I'm looking for a value of here, there's 1, there's 2. No matter where you go along, unless you're at the top or the bottom, you're going to have 2 solutions. Okay. Using CAST rule, what is it? C-A-S-T, I'll do that. I don't use CAST rule, but using CAST rule, what's my next angle going to be? That.
Well, it's positive on the upper left-hand side.
Yeah. If you know it a different way, that's fine. I'm going to show you the way I do it. If you can just get 5 pi over 12 in, so that is what the answer is. I'm going to do it like this. Okay, it works the same way. So the reason that is pi over 6 is here, 5 pi over 6 is here, so it's going to say 2x equals 5 pi over 6, which is 5 pi over 12. Is this coming back to anybody other than me?
Yeah.
One person? Okay, one person. Other than that one person, though, because I want to make sure. So one of the identities that she uses, and I know for all you that I talk grade 11, which is at least Callan, okay? Sorry, Callan, you're the oldest in the class, I'll pick on you. You remember we did 180 minus 360 minus 180 plus. Does that come back to you at all? A little bit. But it is what we did to get for the CAST rule. The other way to think, right, is that this little angle here, which is pi over 6, is going to match the same value as that pi over, is going to be the same value as that. Okay, so that's going to be 5, so that's going to be the same as 5 pi over 6. Pi over 6 and 5 pi over 6 are the same, then you divide by 2. Is that the way you guys learned it from last semester, or so do it a different way? Something like that? See, this is the problem. This is what happens in advanced functions. If trig is last and people go too quickly through it. Sorry? Go ahead.
We did something like 2 plus 2 pi k or something.
Yeah, 2 pi k is what I'm going into right now, okay? Because what I'm going to say is here, we're going to add the period. So what you're adding is plus 2 pi divided by k is what you're adding, right? Because that's going to be what the period is. So I'm going to then do plus the period. So you should end up with 13 pi over 12. And what was that, 17? Okay, I think what I'm going to do for the rest of this week is I'm going to do a pass through a warm-up. Does this look familiar to you at all, Noah Solinger? A little bit. Maybe you don't do a lot of solving equations in advanced function. Maybe that's the problem. Okay, right? But we'll do a little bit of these every day this week to make sure. Does everyone see why there should be 4 answers? Well, somebody tell me, why should there be 4 answers for this? Chris, go ahead.
Is it because of the crest?
Sort of. But I need a more exact answer than that. Why is there, Nathan, why should there be 4 answers?
Because it's all the way 2 pi.
Yeah. So remember, during every period there's 2 answers, right? So from 0 to pi there's going to be 2 solutions, which are these 2. And then from pi to 2 pi there's going to be two solutions, the 2 green ones. All right, so today is May the 23rd. We're going to have derivatives of sine and cos. Okay, from Friday, and I'm going to snub these 2 guys right now.
Like
snub you right now, and you're not allowed to answer this one. Can someone from Friday, if I were to say that f of x is equal to sine of x, what does that phi of x mean, please? Yeah, Cal, go ahead. Very good. Isn't that beautiful? If you guys didn't get to see my proof of that, and I'm trying to decide if I'm going to squeeze it in here, but that's, if there's one thing, guys in the back, please stay with me. If there's only one thing that you get from Friday, it should be these 2 things. Okay, that's why I normally spend like half an hour going through the proof just to sink it into your brain forever. Chris, question?
So then, if with that logic, would that mean that f of x equals cos x, and then derivative of that would be sin x?
No, you skipped on Friday, didn't you?
We're going term paper.
Oh my goodness. Okay, somebody help Chris out here, because he's close to it, he's not exactly right. Can someone recall? Go ahead. Right on. So then therefore, if we have f of x is equal to,
I was in class, I just didn't work on it.
Wow. Jeez, Chris.
okay, we're going to also do tan of x here. Now tan of x is not one you have to memorize, but I'm going to put it in here anyway, just so we can do it here. All right. So example 1, I'm going to find, say.
Wait, why is one box so different?
I'm going to go see the proof. Whoa, sorry. Whoa.
That's what happened.
Whoa. I got too excited, Bill. I apologize.
It's like they're the exact same tree, so.
No, I got too excited. Sorry, Bill. Cos of x is negative sign. That's what I meant to write. Sorry, thank you. Sorry, I got too excited. Sorry about that. Okay, example 1 says find the derivative Okay, and we're gonna do this slowly as a class, okay? And this might be in your notes, but I want you to play along anyway. And just go through this, so I wanna go through every rule that we've used so far, quotient rule, product rule, chain rule, all that stuff you can use for signing codes as well, right? So that's a nice thing about all those rules. You learn anything that's a function, you can use the same rules for, okay? So, can I get someone who's brave and isn't sitting right here? I told you guys I'm something already. Alan, what is tan equal, please? Thank you. So I'm gonna say f of x, and write that first of all. All right, Luke. I see sine over cos. What should you be thinking right away when you see sine over cos? What type of derivative? What type of derivative? Oh, yeah, I heard somebody here say, yeah, it should definitely be quotient, it's a fraction, right? Okay, so do you remember what the quotient rule is, Luke?
I like these ten.
What's that? Okay, somebody else help out, other than Derek. All right, go ahead.
So this is just guessing, but cos x times cos x minus turns into a plus sine x times sine x all over cos x squared.
Okay, hold on a second.
Well, cos squared x, yeah.
Now, let me get out of the way, because I want to make sure this is good. If we're going to start to deal with, can you stand so with you guys in the back, please? We're going to deal with complicated derivatives again, chain rule and all that stuff that's coming back here. So you need to make sure your brains are alive and on today, okay? Okay, what's cos x times cos x the same as?
Cos squared x.
Cos squared x, okay? So this is equal to then cos squared x.
Is this going where I think it's
Wait, I hope so. Okay, now someone in this class, let's call him Brendan. It's not going to be Brendan now. Brendan would try and just do cos x divided by cos x and cancel that. Why can that not work? It's not Brendan that would do this, but about 5 people would do this on the test. Derek, go ahead.
There's no cos squared x in the sine squared x?
Yeah, remember how it has to happen? You have to divide it from both things, not just one of them, okay? Now, there is something I can do here. Now, hold on, Chris, just wait. Go ahead.
Make the top of one.
Yeah, remember the identity, cos squared plus sine squared is equal to 1. So this is just equal to 1 over cos squared x.
Isn't that like 1 over like secant?
Just secant.
Oh, right, secant.
Secant squared it is, though, because it's cos squared. Okay? And that is neat. Trig is magical. Aren't you guys impressed that these derivatives work out so beautifully? I know I am. When I first learned the derivative of sine was cos, I just about fell right over in my chair. That's how excited I was. It was, no, really, I mean, it's actually quite magical the way the nice things that math works.
Okay.
The math works beautifully like this, okay? All right, so I'm just going to make a little note. It's just going to say, remember, all the different rules work the same that we did before. Does this make sense how I got that for most people? It just, again, we're just using quotient rules, all we did there, okay? Brendan, you're good? You good? Okay, sorry for picking on you. I know you wouldn't have made that mistake, okay, but I needed something. So I'm going to say all derivative rules that we have learned before I'm going to say product, quotient, chain, can be applied to sinusoidal derivatives. And this is one nice thing about calculus, and that reason the functions are so important. Once something is a function, any rule that we make can be applied to every single function, which is cool. Okay, right? It saves a lot of time, so I don't have to go through all the basics here. What I do have to go over, though, is finding the derivative of lots of things here right now. Okay, so I have, I think, 5 examples here. We can do this, okay? Have confidence in yourselves. You guys are all awesome. and taking derivatives. Okay, so we're going back to some of those tricky ones again here. I'm gonna put the first one on the board, I'm gonna hit pause in the video, and you guys are gonna do it. Sound good? Okay, nobody who's arguing with me right now, so we'll see what's going on. Example 2 says, find the derivative of f of x equals x times sine x. I'm gonna pause in the video. You guys are gonna do this one. This should be efficient and quick. You guys can do this. All right.
So you know, awesome. That's it for me.
Just wait. Let me hit pause on the video first, okay?